guys, this is Shelby with the Rogers Public Library. So this week I thought since Halloween is coming up we could do some spooky science. And for that I've got some dry ice with us here. Now if you've ever messed with dry ice before, you know that it's very cold. So I'm going to be extra safe. I'm going to wear some goggles while doing science. And I'm also going to be wearing some gloves to protect my hands. If you guys get dry ice, you can buy them at some grocery stores. Not all of the ones around here sell it, but there are some that do. Be extra careful because it's very cold. It's like negative 109 degrees Fahrenheit. So it can give you frostbite. And also if you keep it in a closed room, then a lot of gas builds up and that can be dangerous too. This is dry ice, and it looks a lot like ice, but the difference is that it's not wet. It melts, but it doesn't turn into water. It turns into smoke, right? And you can do a lot of cool things with dry ice. Like for instance, you can put it in some warm water and it makes a lot of cool smoke like this. And so this is pretty cool. It tells us a lot about something called phase changes. But before we get into that, I just want to say, what is dry ice? It is actually frozen carbon dioxide. So if you know about carbon dioxide, you know that it's a gas, right? And it's really easy to make carbon dioxide. Like for instance, we have a seltzer tablet here, and I can put the seltzer tablet in the water, and it makes a bunch of carbon dioxide bubbles. And they are bubbles. It is a gas, and it kind of just floats up out into the air, escaping the water. So what makes dry ice different? Well, it's frozen, right? And to freeze dry ice, you have to get it really, really cold. And actually, at the pressure that the atmosphere is at, you can't. When you freeze dry ice, it doesn't go from a gas to a liquid to a solid like water does, right? Instead, it goes straight from a gas to a solid. So I have this chart here. It's about phase changes, and so there's the different states that matter can be in. There's plasma, which is it's a special type of gas, and there's gas and liquid and solid, and then there's cool arrows here that tell us what the changes, what the phase changes are, right? These are called phase changes. And if you look on the side, there's a little arrow that says enthalpy of system. That just means heat energy, or how hot it is, right? So as the temperature of matter goes up, it tends to turn into a liquid and then a gas and then plasma eventually if you get it really hot. So to turn carbon dioxide gas into a solid, there's a process called deposition. It's actually a two-step process. The first step is you get carbon dioxide gas, and it's really easy to make. You can do it like this, this is a process that makes carbon dioxide gas. There are a lot of processes that make carbon dioxide gas. Like when a car burns gasoline, that makes carbon dioxide gas. And when we exhale from our lungs, that also makes carbon dioxide gas. So it's a really prevalent byproduct of a lot of chemical reactions. So, and you can capture this carbon dioxide gas and use it for useful things, such as dry ice. So this gas is captured and it's cooled down and it's compressed. That's the important part. It's compressed until it turns into a liquid, right? So you can say it condenses. This is called condensation. And then what you do is you expel the liquid, and that when the liquid carbon dioxide expands, it gets super cold. And some of it turns back into gas, but some of it is so cold that it freezes and forms dry ice. Or rather, it forms a kind of whitish powder, and that powder gets compressed into blocks or pellets or things like that, and that is the dry ice that we have here. And so I'm going to break this up with a rolling pin. I'm going to get some tinier pieces. I'm going to drop them in here so you can see a little bit better what happens when we put them in the water. So what's happening is it's called sublimation. The dry ice actually sublimates, like right now, this piece, you can see smoke rising off of it, so it's sublimating right here. But the water is a lot warmer than the room, and it's also better at transferring heat energy. So it speeds up the process, and that's why we get a bunch of smoke at once instead of just a tiny bit. So this is called sublimation. But think about this. When we put the tablet in this water over here, we saw a lot of bubbles, but we didn't see any smoke. So the smoke that comes off of the dry ice isn't actually carbon dioxide. The carbon dioxide is invisible, right? What we see instead is actually water, right? So at any point in time, there's something called humidity, and there's a certain amount of water that is dissolved in the atmosphere. And the amount of water that can be dissolved in the atmosphere depends on how cold it is. So when we put the dry ice in the water and it sublimates, it cools down the environment, right? So if you felt the water right now, it would feel pretty cold, even though when I put the water in the bowl, it was relatively warm. So it's cooling down the water as it expands. And that also cools down the air, and that forces the water that's dissolved into the air to turn back into water, right? Into liquid water, rather than being water vapor or gaseous water. And that's what's actually the smoke that we're seeing, right? So it's almost like a cloud or like fog. Yeah. So that's the chemical processes or the phase changes that are going on when we put carbon dioxide in water. Now, I guess you're wondering, how is this useful? Well, it looks really cool. You can use this for in a mood piece. It almost looks like a witch's cauldron, right? You can also use it to make bubbles. So if I take this big piece in here, right, we're putting more in here, and we're going to put a little bit of soap on top. It's going to make a lot of bubbles. It's going to be a little bit messy. But it makes a lot of bubbles, right? But you can also, when the carbon dioxide turns back into gas, not all of it escapes from the water right away. Some of it actually stays dissolved in the water. And it takes the form of something called carbonic acid. So soda has carbon dioxide bubbles in it too, right? And not all of those bubbles, not all the carbon dioxide in the soda is in the form of bubbles. Some of it is dissolved in the water, just like here, and it forms carbonic acid, and that's what gives soda its kind of sour or bitter taste, kind of like sharp. And so if you tasted this water, which you don't want to do right now because the carbon dioxide is still sublimating, but if you waited for all the carbon dioxide to sublimate and then you tasted a little sip of the water, it would taste kind of like club soda, like soda water without any flavor or sugar in it. And it's a little gross, to be honest. But that's one thing you can do with carbon dioxide and water. Other things that you can do just with dry ice or compressed carbon dioxide is they're used to fight fires. So fires can burn in oxygen, but they can't burn in carbon dioxide, right? So it smothers it and makes the fire go out. And they're also used for refrigeration, right? So because this is so cold and because it turns into gas when it melts instead of water, it's really good at keeping things cold when they're being shipped or being stored for a long time. Because, well, it's colder, so it takes longer to melt compared to ice, and it also won't make your food wet and soggy when it does melt. So it's pretty neat like that. Yeah. So that's the science that I have for you guys this week, and I wanted to talk a little bit. Put these in here. We'll have a little bit more fun. I wanted to talk to you guys a little bit about some crafts that you can do. So these are tissue box monsters. So it's just a normal tissue box. You can use the square ones or you can use the bigger rectangular ones. And I made these two a little bit differently. This one has construction paper on it, right? So I cut out construction paper and I taped it down. And you can see some of the tape on the back and up here. But I put a little bit of paint on it too. And then the teeth are also made out of construction paper, same as this guy. And then more construction paper for the eyes, and little googly eyes, like this. And then this guy, so I mixed some stuff together with paint to give it a nice texture. It's kind of bumpy. And the same type of eyepiece. I've also added pipe cleaners on it to make like antenna type things. Yeah, so these are pretty easy to make. You don't need a lot of stuff. Just pipe cleaners, construction paper, eyeballs, and paint, and tape. Stuff like that. And most people have tissue boxes at their house anyway. So, yeah. So that's what I have for you guys this week. And next week I'm gonna have some more spooky science to show you guys. So tune in then. See ya.